Hi, I'm Ben Davis, Bold Ideas Education Director. At Bold Idea, we strongly believe in learning by doing. In a previous video, we talked about a distinction between teaching and mentoring. The word teaching suggests that your job is to put new knowledge into students' heads. In our experience, the best way for learning to occur is for students to be able to teach themselves. So I'd like to share with you some information on how you can help students become better self-directed learners, how their mindsets can either improve or hinder the learning process, and how you can help them gauge their own understanding while solving problems. Our educational program is not about dumping a bunch of coding knowledge onto our students. It's really about empowering students to teach themselves. This is what's known as self-directed learning, and it's a powerful skill. For us adults, self-directed learning can be a really difficult thing to wrap our heads around when we're trying to help someone else learn. We've spent our entire educational careers having to listen to lectures, memorize facts, vocabulary, or specific processes or methodologies. We then have to take quizzes and tests to make sure our memory hasn't failed us. While this is okay for traditional education, this isn't really how learning works in the real world. According to a recent Stack Overflow survey, 90% of developers consider themselves at least partially self-taught. That means that there are a lot of developers who have already sold themselves as self-taught, got tech jobs, and launched their careers. It also means that employers are getting comfortable with hiring developers from this non-traditional background. To be a successful self-learner, you need huge amounts of determination, drive, and willingness. From an employer's perspective, these are highly desirable traits. I want you to think back to the last time you had to learn something on your own, outside of a classroom setting. Maybe it was learning to code, learning a new instrument, or learning to bake. What was that experience like? What resources did you use to learn? Did you have to wade through several tutorials before you found one that made sense? Did you have to struggle through a task several times before the concepts really sunk in? More importantly, what was your mindset? When things became too difficult, what did you tell yourself? How did you deal with failure? Your students will be in the same place, and you really have to put yourself in their shoes. Remember, start from where the learner is, not from where you want them to be. Help them understand that they don't need to be an expert in coding before they try making something on their own for the first time. Help them become more proficient in finding out what they don't know and where the gaps in their knowledge are. Show them how to use the resources they have available to fill in those knowledge gaps. Students will have access to curriculum guides, practice activities, coding challenges, and tutorials. These can all be accessed from the student portal at my.boldidea.org. They also have their fellow peers whom they can ask for help. Encourage students to help each other. Being able to explain a concept to your peer really helps solidify that concept in your own mind. Students are also free to find help on the internet. Help them learn how to use these resources on their own. Learning to code is no easy task, no matter your age. At some point, things will become difficult. When this happens, pay close attention to the student's attitude. A lot of research today shows that a student's attitude towards learning has a huge effect on the learning outcomes. We also call these attitudes mindset. When considering whether or not we can get better at something, we can have either a growth mindset or a fixed mindset. A growth mindset is believing I can improve and that I always have something to learn. A fixed mindset is believing that my ability to do something can't change. I was born that way and I can't get better. If you've worked with students before or have your own kids, you've most likely heard fixed mindset statements such as, "I'm not good at this. I'll never be good at this. I'm not a math person," or "This is too hard for me. I failed, so I can't do this." Or, "She's so smart, I'll never be that smart." Those are fixed mindset thoughts. The reality is, mindsets can be changed. Simple interventions can switch students from a fixed mindset to a growth mindset. Rather than keeping our fixed mindset thoughts, students can try these growth mindset thoughts. Instead of, "I'll never be good at this," or "I'm not a math person," try saying, "This may take some time and effort. I'm going to train my brain in math." Rather than, "This is too hard for me. What about, I'll keep trying, and with help, I'll get better." Instead of seeing failure as a bad thing, tell yourself, "Every time I fail, I learn something new." Rather than seeing yourself as inferior to someone, you could say, "I'm going to figure out how she does it so I can try it." Students with a growth mindset have different responses to feedback and to failure. They understand the fundamental learning cycle. You try something, get feedback or discover a bug, you learn something, and then you try again. As students are learning, don't expect them to grasp coding concepts right away. Like any other new topic or skill, it requires repetition and different approaches. It's important to help the student learn how to gauge their own understanding. If they're struggling, help them to identify the gaps in their knowledge. Review previous learning activities whenever necessary. When they do have that aha moment, make a big deal out of it. The goal is building confidence and experience being a coder, in addition to building students' problem-solving skills. At some point, though, your students will get stuck. Let's say they're missing a closing tag in their HTML, or they forgot to indent something in Python. They just can't seem to figure out why their code isn't working. Their first instinct will be to look to you for the answer, and you will be tempted to give it to them. After all, that's the easy route. It isn't easy seeing a student struggle with something, but that struggle is essential to the learning process. Giving them the answer is like spoiling the surprise ending to a movie, and no one likes spoilers. Trying things out, failing, and revising are key parts of learning, and we don't want students to lose that approach. So, what do you do in these challenging situations? The first thing is to have empathy and give encouragement. Help them maintain a growth mindset. You could say, "Wow, that's a tricky one, but I'm pretty sure we can figure it out." Your student then might try to fix something by random coding. This is when they try moving things around, deleting stuff, adding stuff without really thinking about what they're doing. If you see this, ask them to stop for a minute and have them talk through their thinking process. Then say, "What did you do before it stopped working? What do you think you can try differently?" If we read that error message again, maybe there's some hints there. When you do realize what it is they're stuck on, hold that answer in your mind as the learning objective. Feel free to give them hints to point them in the right direction, but don't outright give them the answer. Do whatever you can to ease the process of getting them to that objective, but don't just hand it to them. If you know the concept they're getting tripped up on, it's fine to tell them to read a specific section of the curriculum or a reference guide, or remind them of an activity that you did in the past. If your student is stuck on a problem and you're not sure what the answer is either, try working through it together. Your student will really appreciate the fact that you're learning together and will feel more confident in looking for a solution. If after about 10 minutes or so you both can't figure it out, reach out to a subject matter expert on your team to help point you in the right direction. Our computer science curriculum is carefully designed to walk students through basic concepts and slowly build on those concepts so that they can become more self-sufficient coders. Before each session, we ask that you review the learning activities on your own so that you can be better prepared to guide them in the right direction during the session. You can find these learning activities in your Hive dashboard on the resources page under the course info section. Now, if you're a professional coder and you're volunteering with Bold Idea, there's a good chance that you're really passionate about what you do and you're excited to share that passion with these young learners. We hope that you use that to help students become better self-directed learners. When mentoring, however, be careful not to stray too far away from the curriculum's learning objectives. You might be excited to show a student an advanced Python algorithm or some trendy new JavaScript framework. Understand that these students are already being given a lot of new information each session. And the more new ideas you introduce, the more likely it is that they will experience learning fatigue. Remember again to start from where the learner is, not from where you want them to be. It's important to pay attention to the pace at which the student learns and work with them at that pace. It's totally fine if you think of something cool that you think might help keep them engaged, but make sure that they understand that that's not an important learning objective. If you'd like to know the specific learning objectives we've outlined in our curriculum, you can view them in your Hive dashboard on the Resources page under the Course Info section. I hope you have a better understanding of how you can use your own experience in self-directed learning to help students become better at teaching themselves, and how to have a growth mindset, and how to help students gauge their own understanding while learning.